Okay, so in Math 7 today, we will be doing Lesson 1 from Chapter 9. And the title is Probability of Simple Events. And we're going to start with the vocabulary. It says, probability is the chance that some event will occur. A simple event is one outcome or a collection of outcomes. Now, what is an outcome? So here we have the math definition of an outcome is a possible result in a probability experiment. A real world definition, this is sort of like where you would put it in your own terms. Something that you could say there would be the way that something turns out. Maybe you would use even something different, but I'm going to write down the way that something turns out. Like the way, who's going to win the basketball game tonight? We really don't know. We can predict, but if the outcome is just the way that it turns out. Is it going to be Kansas? Will it be North Carolina? We really don't know right now. We'll know tomorrow. Not they, it's the way that something turns out. No, it's just the way that something turns out. The results. This you don't have to write down exactly what I'm doing, but just another. Okay, this should be a pretty easy lesson today. Real world link. For a sledding trip, you randomly select one of the 4 hats shown. Here are the 4 hats. Complete the table to show the possible outcomes. Well, outcome 1 could be green hat, or you could choose the blue hat. Now, you don't have to put these in the same order as I have. Then I'm going to say purple hat, and my last one's going to be red. Purple and red. I guess we should write the word hat here. At times, kids, I won't make you write the full words out because it takes too long, and I'll tell you that when we do our homework. I'll let you use letters. It's faster. Now, write a ratio that compares the number of blue hats to the total number of hats. Well, there is 1 blue hat, and how many hats are there altogether? 4. So there, remember the different ways you can write a ratio? You can write it as a fraction, the dot dot, or the TO. That's the way that you can write a ratio. Describe a hat display in which you would have a better chance of selecting a red hat. Well, you could add 4 more. You could do something like in the display, you could add 4 red hats and 2 blue hats. And then you would have a better chance of getting a red hat. We don't have to write that down, but you all know if you have more red hats than other hats, then you have a better chance of getting it right. Here, they're all equal in this picture, but if you wanted to make it so you could have a better chance of getting red hats, you just put more red hats as your choices. Okay, now let's go to page 712 and look at what we have going on there. It says, what is probability? The probability of an event is a ratio that compares the number of favorable outcomes to the number of possible outcomes. Favorable outcomes are the outcomes that you want. Like if you're wanting to choose red hats, it's pretty easy. Okay? Now, the probability of a chance event is a number between 0 and 1 that expresses the likelihood of the event occurring. Greater numbers indicate a greater likelihood. A probability near 0 indicates an unlikely event. A probability around 1/2 indicates an event that is neither unlikely nor likely. And a probability near 1 indicates a likely event. So if the probability is 1, kids, it means it definitely will happen. If the probability is 0, it means it's impossible. So see this chart? It's sort of a nice chart. I like the colors. Here, it's impossible. Here, it means it definitely will happen. 1/4 is unlikely. 1/2, it's a 50-50. It can go either way. Likely, 3/4 is likely. All right? It says, outcomes occur at random if each outcome is equally likely to occur. Then it's random. Okay? It says, stop and reflect. It says, in the space below, describe an example of a simple event that is certain to occur. Okay, can you think of something that is certain to occur? Yes.
Somebody will win in the next basketball game.
Someone will win in the next basketball game. That is definitely going to occur. Right. Rolling a number less than 7 on a 6-numbered dice is certainly going to happen because all the numbers on the dice are less than 7. So those are all examples of things that are certain to occur. Now let's go and look at our example problems. There are 6 equally likely outcomes if a number cube with sides labeled 1 through 6 is rolled. Now look at how they write this. Find the probability of a 6. That's how you read it. Find P6, or the probability of rolling a 6. It's much easier to write that than to write this. Don't you all agree? So everyone understands what that says. There is only 1 6 on the number cube. So this is how you write it. The probability of rolling a 6 is the number of favorable outcomes. Well, there's 1 6. Out of the possible outcomes, there are 6 outcomes. So the probability of rolling a 6 equals 1 to 6. Does everyone know what that means now? This is easy, but we're learning the language of how to communicate it. And nothing's worse than you know how to do it, but you didn't understand the language. Now it says, the probability of rolling a 6 is 1/6, or about 17%, or 1700ths. Now, how do you change 1/6 to a decimal or a percent? You just have 1 divided by 6. And if you can have a calculator, it's much easier. Subtract. And let's see, it'll go into it 6 times. Well, they rounded it, because you will get 0.6 repeating. So 0.16 repeating would be 0.17, and 0.17 equals 17%. So do you see how I got the answers here? All right, now let's go to letter A. A coin is tossed. Find the probability of the coin landing on heads. Okay, how many heads does a coin have? 1. And how many outcomes? 2. So write your answer as a fraction, a percent, and a decimal. So the probability of the coin landing on heads is 1 out of 2. That's a fraction. My percent, you know, is the same thing. It's 50%. 1/2 is the same thing as 50%. And as a decimal, it is 0.5. So they wanted a fraction, then a percent, then a decimal. Any questions on how to do that problem? Okay, let's go to the next page, 713. Let's look at example number 2. It says, find the probability of rolling, a 2, a 3, or 4 on the number cube. Okay, this is how you would write it, the probability of rolling a 2, 3, or 4. How many ways can that happen? 3. How many possible outcomes are there? 6. 3/6, which is 1/2, which is the same thing, 1/2, 50%, and 0.5. Any questions? Now we're going to do the same thing, but with the B, C, and D, you're going to use this color spinner. What's the probability of spinning an F? I'll do the first one for you. Well, there's just one F. And how many are there all together? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1/10. That's my fraction. 1/10 would be 10%. And as a decimal, it's 0.1. So those are the 3 answers. I guess I should have written them on the blanks. 1/10. That equals 10%, and that's the same thing as 0.1. Any questions? Go ahead now and do C and D. So for letter C, you have 2/10. That simplifies to 1/5. So you would have 1/5, that's 20%, and 2/10. Vowels, there are 3 of them, A, E, and I on the spinner. So that's 30%, 3/10, which is 30%, and 0.3. Any questions on how to do those? All right, now let's look at find the probability of the complement. All right, what are complementary events? They are 2 events in which either one or the other must happen, but they cannot happen at the same time. For example, a coin can either land on heads or not land on heads. The sum of the probability of an event and its complement equals 1 or 100%. Okay, now let's look at example 3, and I think it'll make a little more sense. Find the probability of not rolling a 6 in example 1. Well, the probability of not rolling a 6 is 5 out of 6, right? There's only one way. So, it says the probability of not rolling a 6 and the probability of rolling a 6 are complementary. So, the sum of the probabilities is 1. So, the probability of rolling a 6 is 1/6. The probability of not rolling a 6 is 5/6. You add them together, 1/6 plus 5/6 equals 1. And that's its complement. So the complement to 1/6 is 5/6. The complement to 5/6 would be 1/6. And that's where you get complementary events. When you add them up, it equals 1. So let's go to letter E. It says a bag contains 5 blue, 8 red, and 7 green marbles. A marble is selected at random. Find the probability the marble is not red. Okay, so what's our not red? The probability of not red. Well, the probability of red is 8. Not red will be 5 plus 7. So it's going to be 12 over, what is that when you add them together? 20? 12 over 20. Now, on this we have to do it, they want us to do a fraction, a decimal, and a percent. It doesn't say it in that question, but that's what they want on the answer blank. So 12/20ths will simplify to 4 divides them both. 4 goes into 12 3 times, 4 goes into 25 times. So we have the fraction 3/5. 3/5 will equal what? 60%, and 60% is 0.6. Any questions? I'll be honest, whenever I was thinking of this, it's like, well, 20 times 5 is 100. 12 times 5 is 60, and 60 over 100 gives me my percent. So anything over 100 is your percent. Let's go on to 714 now and look at our 4th and final example. Mr. Harada surveyed his class and discovered that 30% of his students have blue eyes. Identify the complement of this event, then find its probability. Well, kids, the complement means 30 plus what is going to equal 100? 70. The complement is going to be 70% because 30% plus what? 30% plus what equals 100%? Well, you know it's going to be 70%. But let's go through the formal steps. The probability of blue eyes plus the probability of not blue eyes has to equal 100%. So 30% plus probability of not blue eyes equals 100%. 30% plus 70% equals 100%. So 70%, 0.7, and 7/10. Any questions on that? Okay, let's look at our guided practice. We have these letters over here. They sort of are like spring pastel colors. A letter tile is chosen randomly. Find the probability of each event. Write each answer as a fraction, percent, and a decimal. Okay, what's the probability of a D? Well, it looks like there's only one out of 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 1 out of 9. Okay, now we have to change that to a, I'm going to change it to a decimal and then go to a percent. And I share my room and I don't see my calculator. Does anyone happen to see a calculator? That's the problem when the other kids come, here's one, into the room. Sometimes my things will disappear. So 1 divided by 9 gives you the decimal 0.1 repeating. Okay, so my decimal is 0.1 repeating. Okay, because it goes on and on forever. So I'm going to do that as 0.11. So the percent will be 11%. Okay, I'm just going to do it so it's 2 decimal places. So that will make it 11%. Any questions on that? If this were a test or a quiz, it's going to be very specific about where to round it to. Okay, here it wasn't. An S, a V, and an L. Well, there's one S, one V, and one L. So it's 3/9. That simplifies to 1/3. That is 33 1/3%. And the decimal is 0.3 repeating. You should have 1/3 memorized as 33 1/3% and 0.3 repeating. Okay. Now, if they wanted it rounded, it would be 33%, and that would just be 0.3, or I guess 0.33 would round it 2 places. Okay, what's the probability of not a D? Well, how many of the letters are not D's? 8/9. And 8/9 would be 8 divided by 9, which is 0.8 repeating, which would be 0.89. See how that would be 0.89? So that would be 89%. Now, does 89% plus 11% equal 100%? It does, because these two are complementary events. The probability of D plus the probability of not D has to equal 100. So that's one thing. If they would ask that question, make sure when you add your percents together it equals 100%. Otherwise, I'd have to count it wrong. Number 4, the probability of choosing a go back 1 space card in a board game is 25%. Describe the complement of this event and find its probability. Okay, the probability of choosing a go back 1 space card is 25%. So the complement of that event would be the probability of not choosing a go back 1 space card. I didn't want to have to write everything out, so go back 1 space card is its complement. And that would be what? If this is 25%, what's the complement to 25%? 75%. Okay, describe the complement of this event and write its probability. It's going to be 75%. If you have to write it 3 different ways, that's 3/4 and 0.75. Any questions? Okay, now what are we going to do for our homework tonight and classwork? So, on page 400 or 715, do all. Okay, turn the page. 716. Let's see. I would like for you to do 7, 8, and 9, and number 11. Do 7, 8, 9, and 11. And that should be enough. I don't think I'm going to have you do any of the problems on the other pages right now. So there you go. And let's see, we have plenty of time. If you get finished, you can go ahead and do page 717. These are all pretty good problems too, on page 717. So if you get finished, you can do those problems too. All right, there you go.